So good evening everyone and welcome to this lecture, and for a long time we are moving on to electrostatics. Now since you have covered electrostatics to some extent, we will try to move quicker through this part. Electrostatics. When you hear the term electrostatics, what does it stand for? Electro stands for electricity and statics means for rest. So electrostatics is basically study of charges at rest. But that does not mean that charges are not going to move. Basically, what electrostatic means is we are going to study what charges do when they are at rest. When they are at rest, charges create electrostatic fields. So that is what we are concerned about. The charges are going to move in this chapter as well, but then we are not going to take their other fields that they produce into the picture, and therefore we call this chapter as electrostatics, or the study of what?
Charge address.
Charges at rest. Now as soon as we understand that it is the study of charges at rest, we must understand a few properties of charges. We will go through them very quickly. Do you remember the properties of these charges? Remember the property of these charges? First, tell me, what are the properties of these charges? I hope you have written them down somewhere. Anyways, I'll go through them very quickly. If you want to, just you must be having the previous notebook, just open it and just keep on ticking those things. If there is something that you have not written, just write it. Charge is a scalar quantity, we know this, yes or no?
Yes, sir.
Charge is transferable. If you have two bodies, positive and negative charge, they can flow from here and there, yes or no?
Yes, sir.
Charge is always associated with mass. Do we understand this? Every charged particle has some mass. Charge cannot exist without mass, but mass can exist without charge. There can be bodies which has mass but no charge. Now, what do you mean by a body having no charge and body which is neutral? A body having no charge means it does not have any charge at all. It does not have positive charge. It does not have negative charge. Can you name a body which has got no charge? First. Huh? A body which has no charge.
Neutron, sir.
Neutron is a body that does not have charge, but it has mass. So that is a body with no charge. So mass can exist without charge, but charge cannot exist without mass, because the most fundamental quantity of charge that we have is the charge of an electron. An electron or proton has mass. So charge cannot exist without mass, but mass can exist without charge. Now there are bodies which we call neutral. What do you mean by neutral bodies then? Do neutral bodies have no charge? No, neutral bodies have charge, but they have an equal amount of positive charge and an equal amount of negative charge. What is the body that creates positive charge? What is that thing that creates positive charge? Huh? Now remember, we say that a proton is positively charged. Yes or no?
Yes, sir.
A proton is positively charged. Who told that the charge is positive? It's an assumption. We assume that the charge on a proton is positive and charge on an electron is negative. That is a pure assumption. That is a pure assumption. Because we found out that charges are of two types. Mass is of only one type, but charges are of two types. We called one of them as positive. We call other of them as negative. We could have called them by other names. We could have called them Ram or Sham. We could have called them Newton and Einstein, but we called them positive and negative. So it's a just assumption that proton is assumed to be positive charge and neutron is supposed to be negatively charged. Do we understand this? Yes or no? These are pure assumptions.
Yes, sir.
These are pure assumptions. Charge is conserved. You can create charges, you can destroy charges, but charge is always conserved. What do you mean by creating charges? When you say you are creating a charge, what it basically means is you are creating an imbalance of what? You are creating an imbalance. When you are saying that you are creating charge, you are basically creating a imbalance. Imbalance of what? There are protons in the nucleus, there are electrons moving out in the outer shell. Normally, an atom is neutral. Whatever the number of protons, positive charge, is same as the number of electrons. How you can charge a body? What do you mean when you say body is charged? What do you mean by that? In normal cases, what do is you change the number of protons and electrons. What is easier to do? To change the number of protons or to change the number of electrons? Do it fast. You know that you knew this already, right?
Change number of electrons, sir.
Change the number of electrons, because if you change the number of protons, the nucleus changes. So if atom has, because of imbalance, more number of electrons than the number of protons, it is negatively charged. If it has less number of electrons, then it is positively charged. Do we understand this?
Yeah.
Then we have got something known as invariance of charge. Have you heard this term, invariance of charge? Have you heard this term, invariance of charge? Invariance of charge means the value of charge does not depend on velocity. The value of charge does not depend on velocity. When things move and it comes closer to the speed of light, the mass of the body changes, but the charge of the body does not change. A charge can produce electric as well as magnetic field. We know this, yes or no? Here we are only going to study the electric field, and this is how. That is why it is known as electrostatics, because we are going to study what a stationary charge does. A stationary charge only creates electrostatic field. So this is the study that we are going to do. Do we understand this? Yes or no?
Yes, sir.
Yes, sir.
In the chapter that is going to come after probably a month or so, it is going to move with a constant velocity, and therefore you will have, apart from electric field, you will have this B also coming. What is this B? This B is magnetic field. A charge moving with constant velocity produces both electrostatic as well as magnetic field. A charge which is accelerated, and that will come in the last chapter, will radiate energy. It will create electromagnetic waves. That is the last chapter of this discussion. Do we understand this?
Yes, sir.
You know this, yes or no? I have to move quickly here so that we can move. I hope you have noted all these points. Any of these
Sure.
points can come as a question in your exam. That is why I am telling you. So I hope that you note them down properly if you have not noted down still. Charge is quantized. It comes in packets. We saw in the previous chapter that light is also quantized. Number of photons, particle, dum. The smallest particle of light is known as photon, dum. The smallest particle of charge is known as charge of an electron or charge of a proton. Do we understand this?
Yes, sir.
Okay, this is all about charges. You must also know the methods of charging a body. Yes or no?
Sir.
How can a body be charged? Just tell me fatafat. How can a body be charged? Eh?
Conduction, sir.
Only conduction?
Induction, sir.
Only induction. Okay. Methods of charging. Fatafat, I will go through this. The first method is by charging by friction. You rub your body, dung, and electrons may get transferred from one place to another. That is known as charging by friction. We all know this, yes or no? Hmm? Yes or no?
Yes, sir.
Then the second process of charging, I will not give you examples of this because you must know it. Second process of charging is charging by induction. You bring a charged body near to an uncharged body and things start to happen. Yes or no? That is
Yes,
known
sir.
as charging by induction. I hope you know this. These are simple things. If you want to have a diagram, you can have a diagram as well. We are supposed to move quickly, and so you can see a body, a charged body is brought near a uncharged body and things start to happen. Yes or no? Then there is charging by conduction. For this conduction, what you got to do is you have to bring two bodies in contact. Yes or no?
Yes, sir.
So that is the third process, third way of charging, that is known as charging by conduction. The process of transfer of charge by method of contact of the two bodies is known as charging by conduction. We understand this? Okay. We understand this?
Yes, sir.
Here comes a question on this. Do it fatafat so that we can lock this topic and move ahead in life. So this is the first question. 10 raised to the power 12 alpha particles, which is helium nucleus, per second falls on a neutral sphere. Calculate the time in which the sphere gets charged by 2 microcoulombs. Questions of this nature are coming in exam these days, and that is why we are doing them. Yes. I'll give you 1 minute to do this. Yes, anyone with an answer, my dear friends? Huh? No one with an answer. Okay, don't worry. That is why I am doing this from the very beginning. That is the only reason, my dear friend. I hope you understand the reason. Because I know what type of questions are coming, likely to come. And I'm not sure whether you have done this or you can do this. That is the reason that I'm starting from the very first class and not where you wanted me to start from. One more minute. Is anyone trying the question? Yes or no? Huh? I can't see you. Your all cameras are off.
Trying, sir.
Okay, sir. Give me the answer, sir. I'll give you sufficient time. Remember, the only purpose of my class is whatever we do, we should be able to solve the question when it comes in the examination hall. That is the only purpose of our discussion or any class that I do, so that you should be able to solve the question, nothing else. This is an elementary question, beta. I know that. Yes, beta, tell me, answer.
5 seconds.
5 seconds, let me check the answer. It is 6.25 seconds. So, I'll give you 1 more minute. Don't worry, I know that you have done this chapter, done this part, but probably you have done this, I don't know, maybe 2 or 3 months back. 2 or 3 months is a long time to lose things. More importantly, when you don't practice them. You can lose it. That is the reason we start from the beginning. Would you want to try more or shall I do it for you?
Do it, sir.
Done?
Do
Anyone
it,
got
sir.
that? Yes? I should do it. You're not able to do it.
Sir.
Alpha particles. What do you mean by alpha particles? I told you about alpha particles in the chapter on photoelectric effect. Yes or no? What is alpha particles?
Helium nucleus
Helium nucleus. What is the charge of an alpha particle?
+2.
+2. But that's it. That is the only information that you need to solve this question. If you have that information, you should be able to solve the question. It's that simple as that. With that information, how can you solve the question? You know how much charge you have to give to the body. Yes or no?
Yes, sir.
You know what is the charge of an electron. Yes or no?
Yes, sir.
Just put the values. You know the rate of the electrons falling. You know how many particles are falling. What is the charge of one particle? And you just do simple maths and you are there with time. I still give you 1 minute. I want you to do it on your own. That is the only thing that I want, is that you do it rather than me doing it for you. That is the only thing I aspire, because I know you can do this. It has got nothing that I can it's more about the dimensions of this one. You just have to look at the dimensions of this and you will be able to do this. Just have to look at the dimensions. Chalo, I will do it. If you are finding it so difficult in doing it, I will do it.
Sir.
Got it?
Yes, sir.
Okay. It's very simple. See, it's all about maths, not much of physics involved. If I say that the total time is t, the number of particles falling on the sphere will be 10 raised to the power 12 alpha, because they are falling per second multiplied by t. These are the total number of particles. The charge on one particle is 2 times the charge of an electron. So the total charge falling will be 10 raised to the power 12 multiplied by t multiplied by 2 into 1.6 into 10 raised to the power minus 16 coulombs. And that must be now equal to 2 into 10 raised to the power minus 6. Just equate the two and you will end up with the time. And I think the time is coming as 6.25 seconds. Do we understand this, everyone? So if there is a question of this nature, this is how you must do it. Shall we move ahead? Everyone understands it?
Yes, sir.
That takes us to the first thing of this chapter, which is known as your Coulomb's law. Can anyone tell me what is your Coulomb's law? Coulomb's law. It gives us what? You have two charges, Q1 and Q2, separated by a distance r. What
The distance between 2 point charges.
it gives what, beta?
F is equals to KQ1 Q2 by R square.
It gives us the force between the two particles, two charged particles. Remember, these two charged particles are considered as point charges, or if they are big charges, the distance between them is very big compared to the dimension of these charges. So this is Coulomb's law, which is valid only for what?
Point charges.
2-point charges. It's only valid for 2-point charges. So this electrostatic force will be K Q1 Q2 by R square. Now this K is a constant which depends on what? This K is a constant. It depends on something. What does it depends on? You know this?
Relative permittivity, sir.
K is known as relative permittivity. No.
Epsilon naught, sir.
K is not known as epsilon naught, sir. I'm saying what does this constant K depend on? It depends on
Dielectric odds.
I don't know what you are talking. It depends on the medium. This constant K depends on the medium in which the charges are kept. This constant K depends on the medium on which charges are kept. If I talk about this force in vacuum, and I hope you have the notes, you can just add my notes in that note that you have. In vacuum, if I talk, the force can be written as 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So your K for vacuum becomes your 1 by 4 pi epsilon naught. Do we understand this?
Yes, sir.
This value for K for vacuum, because it depends on medium. K for vacuum is 1 by 4 pi epsilon naught, and when I calculate this value of 1 by 4 pi epsilon naught, it will come same as 9 into 10 raised to the power 9 Newton. What is the unit? Meter square per Coulomb square. This constant K is sometimes known as Coulomb's constant. We can also call it the Coulomb's constant. This epsilon naught is known as what?
Relative permittivity. Permittivity absolute, sir.
This is known as permittivity of vacuum. What it is known as? Permittivity of vacuum or free space. Please remember the terms and don't mix them up. Because if you mix them up, beta, then you are going to land up in big trouble. Don't mix terms up. You understand this, bacha?
Yes, sir.
Do
Yes,
not
sir.
mix up terms. This is known as absolute permittivity of free space. Free space means vacuum. And the value of this is, no one is going to ask you that value, so you don't have to worry about it. But if someone asks you, you can write it as 8.85 into 10 raised to the power minus 12 Coulomb square per Newton meter square. Absolute permittivity of free space or vacuum. This is the formula in vacuum, but if I have these two charges in a medium, then what is the formula? What will be the formula when these two charges are not in vacuum, but they are in some medium? In any other medium, what is the formula like? They're surrounded by some other medium. So basically, what you have is scenario like this. And I'll give you an interesting case here also. So you have these two charges separated or surrounded by a medium of dielectric constant K. Then what is the formula now? I'm not going to use dielectric constant. I'm just going to tell you the formula. The formula now becomes 1 by 4 pi epsilon naught epsilon r Q1 Q2 divided by r square, where this epsilon naught, epsilon r is known as, this epsilon r is known as,
Relative permittivity.
yes, this is known as relative permittivity of the medium. We understand this? It is known as relative permittivity of the medium. Now, this entire term epsilon naught into epsilon r can also be written as, so I can write this force in this form also, 1 by 4 pi epsilon into q1 q2 by r square. You can also write it epsilon m. This epsilon becomes what, bacha? This epsilon now becomes, this epsilon now becomes permittivity of the medium. Do we understand this?
Yes, sir.
So remember these terms, do not mix them up. Now sometimes, and we are going to see in the topics that are going to come, this epsilon r is also known as k. The other name of this epsilon r is also k, and therefore it is also known as what? Dielectric also known as dielectric constant. So this k sometimes also known as dielectric constant. So far so good, bacha?
Yes, sir.
Okay. Now if I give you this small question, now instead of what we had seen here is this two charges are separated completely, I mean surrounded completely by a medium of dielectric constant k or relative permittivity epsilon r. Now we can have a question, and I've seen this question in one of the exams. So I'll put it as a question, or I will put it as a note. So now we come to this case. The case is like this. The complete space between the particles is not filled up. It's not of this medium. We only have a small space in between these two of thickness t. The force, the distance between the two charged particles still r, but I have a dielectric of dielectric constant k, or I have a medium of dielectric constant k, or I have a medium of relative permittivity epsilon r in between these two, whose thickness is t. What is the formula of force now? Think about it. I'll give you 2 minutes. Have you understood the question, bacha? Have you understood the question, bacha? No? I can't see you. Any idea how will you do this? Well, let's not waste much time on it. Time is a luxury that we don't have. Now, how it is done, the simplest way to do this is, what we are going to do is we are going to find the effective distance in air, and then we convert that effective distance from medium to air. Don't worry about it. You just remember the result that you get. And the result that you get looks like this. And you can test the result for different values. So the force now becomes 1 by 4 pi epsilon naught. Now, R minus T plus T times root over K square into Q1 and Q2. Now you can put the value of T as 0. If you put the value of T as 0, it becomes the force between two particles which are surrounded by vacuum. If you put T as R, surrounded completely by the medium, it gets the formula that was present originally. Do you understand this? So remember this.
Sir.
Okay? Remember this. If you get a question on this, it would be a straightforward question. You just mark this option and you move ahead. Okay? Don't have to worry much about it, how it is achieved or what gets this. It is how we have found out. We have basically converted. We have basically converted what? We have basically converted the distance of dielectric from dielectric to air and air to dielectric. Okay. This is as simple as this. Then there is vector form of Coulomb's law. I am not going to tell you that vector form. Do you know this vector form?
Yes, sir.
Yes, I'll just show it to you. And we are hardly going to use this vector form ever. We only use this vector form when the question is given in the form of vector, or the question is given in 3 dimension, and that question is very unlikely to come. Just show you how it.
F equals to K Q1 Q2 by R cube into R vector.
Yes, you can write it. You can write it in many ways. You can write it in many ways. You just have to understand the meaning of this. F12 means force on 1 due to 2. R12 means position vector of 1 with respect to 2. Do we understand this?
Sir.
So let's not get much into this, because we are not going to use this one ever. Very hardly you will see a question. Just let me just give you this one small question that I saw, and I think it is in your module also. I think you would have done this, but anyways, I will have to keep on checking what you have done and what you have not. So this is the question, and give me the answer. Fatafat. Particle of mass m carrying charge q is revolving around a fixed charge minus q. You must know that like charges repel each other and unlike charges attract each other. Yes or no?
Yes, sir.
A particle of mass m carrying a charge q1 is revolving around a fixed mass minus q in a circular path of radius r. Calculate the period of revolution and the speed. I'll give you 2 minutes to do this. Have you done this question before?
Yes, sir.
Then you can tell me the answer straight away. This is a very simple question and a popular question. Yes, what is the answer? Yes.
T equals to root over 2 pi r square m by k q1 q2.
V is equal to root over k q1 or k q1 q2 divided by mr ka square root. And time period? Got the time period also? Everyone got the answer?
T equals to root over 2 pi r square m by k q1 q2, sir.
Okay. I think that looks good. How are you supposed to do this? It is very simple. You have a minus q2 charge here and you have a plus q2 charge revolving. Let us say the velocity is v, the mass is m, and the charge is plus q1. So what should happen here? Anywhere, whenever you have something revolving in a circle, moving in a circle,
Centripetal force.
someone must give it centripetal force. Who is going to give it the centripetal force? It is basically attraction, the force of attraction between the two gentlemen. What are the two gentlemen? K, Q1, Q2. Remember, here we are talking only about the magnitude of force. So even if the charges are positive, we take them as positive. Even if the charges are negative, we still take them as positive because we are talking about the magnitude of force. Do we understand this?
Yes, sir.
Okay, Q1, Q2. Let me call the radius of this circle as R. We call the radius of this circle as R. So the centripetal force becomes K Q1 Q2 divided by R square. Now this centripetal force must be equal to M V
VR.
square by R. From here you can calculate the value of V. You can also calculate the value of V by R. V by R becomes omega. So V by R becomes your omega angular velocity. Do we remember this?
Sir.
And that angular velocity is 2 pi by t. So from there you can also calculate the time period. Yes or no? Do you understand this, bacha?
Yes, sir.
Okay, then we can quickly move on to one of the major concepts which we'll be discussing in the next class and solving questions on this. Probably by the next class we should be able to come to where you were before this. So this is known as the principle of superposition. Do we understand the principle of superposition? Principle of superposition. Have you heard about this principle of superposition?
Yes, sir.
Yeah. So what is the simple of now this is valid for any two vectors. What it basically means is
Sum of F net equals to.
if you have more than two charges present, this charge q is going to experience force because of many charges. F1 because of charge 1. It might experience F1 because of charge 1, F2 because of charge 2, F3 because of charge 3, and so on. Now remember, force between two charges does not depend on the presence of any third charge. So this charge, capital charge Q, will experience F1 no matter other charges are present or not. That means these forces are independent of each other. These forces are independent of each other. It is the same principle as we see as superposition of waves. Did I tell you superposition of waves?
Yes, sir.
The same principle here. One wave present here does not affect the other wave present here. So the net displacement is y1 plus y2. Here the net force is
F1 plus F2 plus F3.
F1 plus F2 plus F3 and so on. Do we understand this? So using this, we should be able to find out the forces in a large number of cases, yes or no? Whenever we encounter any question of more than two charges, we must apply the principle of forces. So remember, forces are a vector quantity, so you must think about the direction apart from the magnitude. Do we understand this? Yes or no?
Yes, sir.
There is a small question that came in one of the engineering exams. You can quickly go through this so that in the next class we can move further ahead from this. Three equal charges plus q are placed at the corners of an equilateral triangle of side A. What will be the force of any on any charge? So basically he's asking you to take any of the charge. What will be the force on any of the charge? So you can take any charge out of those three. So what will be the force on any of the charge? Remember, the triangle is equilateral.
Option D, sir.
Option D is absolutely correct. How do you get it? In very short, this is Q, this is Q, all plus Q, this is also plus Q. Now remember, all the sides are same, all the angles are same, so all the forces are going to be same. Because of this charge Q, it is going to be repelled. This will be the force F. Because of this other charge Q, it is also going to be repelled. We call this force as F. Both have the same magnitude. Why they have the same magnitude? Because everything is same. Yes or no? Then these are just two vectors. There are different ways in which you can find out the resultant. You must know that you will find out that the angle between these two forces is 60 degrees. Yes or no, bacha?
Yes, sir.
So you can use f1 squared plus f2 squared plus 2 times f1 f2 cos theta. That is one way of doing it. Or the other way of doing it would be you will
2f
resolve.
cos theta by 2.
Yes, you can resolve these forces along two perpendicular directions. So you can see the horizontal components will get cancelled and the vertical components will get added up, and you will end up with your final answer. Yes or no?
Yes, sir.
Sir.
Okay, then there is a small question here which I will give you, and if you can tell me the answer quickly, because I need to finish the class. This one. This one. Equal charges Q are placed at the corners of sides of A, B, C, D of a square of length L. The magnitude of force on the charge at B. You can take B as any point. Doesn't matter. You can find this one out. Yes or no? So this is Q, this is Q, this is Q, and this is Q. You just need to find force on any one of the charges. Let me find the force on this charge. You can do it on your own, yes or no? You can do it. Okay, I'll give you this question as homework, and I hope you can give me the answer. You can solve this. It's a very simple question. These type of questions have come many times, and that is why we are doing them. That is the only reason of doing them. The next class, I have sent you the sheet. Did you get the sheet for electrostatics? No. Okay, I'll check again. Have you got the sheet for electrostatics? No. You've not got it. Okay, I'll check and I'll send the sheet today by tonight. So probably by tomorrow morning you should get the sheet. You should concentrate on the sheet. Try to solve question from those sheets. Okay. Because
Sir,
those are
D.
yes, beta.
D.
B. B is not correct, beta. C is the answer.
D, sir.
I think C is the answer that is given to me is C. So we'll try and solve it again in the next class. Don't worry. I'll tell you different ways of doing it. You can just choose the fastest way which you think is the fastest. So I'll see you in the next class tomorrow. Take care and have a nice day. Bye bye.